Welcome to Func Prog Sweden 4. Finally, we're both live on YouTube and we have a live audience. Yes, finally. We're super happy to finally be doing this. Yep, my name is Magnus. Maybe some of you know me, some of you might not know me. After this night, hopefully more people will know me. I hope so. The agenda for today, I will do an introduction, short introduction. Then we will go to functional thinking is solid and clean by Juan. And then we'll have a presentation, the power of functional composition in Swift by Reda. And in the end, I'll do a short schedule and summary. First up, I would really like to thank Volvo for sponsoring both with the venue and with the food, and also with the live streaming. So thank you very much, Volvo. Really appreciate it. I reached out to Volvo and asked if they can do a presentation, and they returned and said, well, maybe, but we can support you with the venue if you like. So thank you very much, Volvo. Yes. Also, if you want to support the MeetUp, of course you want to do that, join the MeetUp group. Join and follow us on the YouTube channel. And if you're really a fan, you get a t-shirt that you can find on this Func Prog Sweden myspreadshop.net. Yes, it's a lovely gift. I've given it to my wife. That's how much she likes it. If you have questions during the presentation, online, please use the YouTube chat and I will read the questions to the presenters. If you're here in the audience and you have a question to the presenter, I will send out the mic, otherwise the people online will not hear you. Or the presenter can read back the question. Yeah? Kind of easy. So, with that, let's get started. First presentation. Functional thinking is solid. By Juan. Welcome.
Thank you.
Now we'll do the magic switch.
Yes, hopefully it works.
Oh, yes.
Always.
It always works, right?
Technology never fails.
No, it's done by developers. They know what they're doing. Yeah. No. I'll take this one.
Okay. It seems that we are good. Let me see, where is my mouse here? So everyone, mic is working well?
Yep. Yes.
Perfect. So let's, or trying to connect. No sense. I shouldn't have closed my computer. Wrong Wi-Fi. There is always a detail. Turn it off and on.
You don't have internet connection?
Yeah, I'm. It is working on that, but should be connected to that one. For some reason, it's not working.
Let's start.
Okay, maybe I can. It's working on offline. Why is not allow me to present on? Was your computer having Wi-Fi? having internet.
You can go into the internet first, maybe you have access to
I had Volvo Cars guest. And it was Volvo Studio.
Yeah.
Yeah, try to open Google. You need to like press some kind of OK or stuff.
You want Wi-Fi?
Yes.
This one.
Yeah, but I am trying to connect to that one. I was connected before. This connect.
Did you connect to the Volvo network one?
Yeah. It's not forgetting the previous one. See? Okay. Now we go.
I think you have to go in that site.
Good. Okay. So finally, sorry for that.
It's been a while we did this live.
Yeah. So, yeah, I want to start by thanking Volvo again for this opportunity. I'm actually I should disclose that I work for Volvo. So I want to highlight a bit what Volvo is doing lately, what type of transformation we are doing, from being a car manufacturer to being more software-oriented company and building the services around the car. So within that context, in Volvo we have some big bets. The first one is that Volvo wants to go fully electric by 2030. We want to be a climate neutral company by 2040, meaning that every car, everything that we produce has 0 carbon emission. We are in-housing pretty much all the software development. And for this, we are, maybe you have read on some posts that we are starting a hub here in Stockholm, where we are expecting to have around 700 positions, mostly on technology and software engineering. And as well, one of the goals is to go fully online sales. A big change on Volvo mentality was to be more focused on the relationship that Volvo has with the customer and try to offer the whole journey, not just the car. Right? So within that, we are as well worldwide. We have offices in China, US, some in Spain, some in India. There are a lot of jobs, a lot of open positions that we are trying to cover. You are welcome to visit and learn more about this. And after doing a bit of publicity, let's go to the functional thinking is solid. The idea of this talk is not to dig deep in details about functional programming. It's not to teach functional programming either, but mostly to see how some functional concepts, when we apply it on our day-by-day work, even if we are developing on object-oriented languages, and within a pseudo-object-oriented architecture, they can guide us and make our code clean and solid, which is the principles maybe broadly adopted by object-oriented programmers to define what means clean and readable code, right? So before jumping into it, who am I? I'm Juan Chiaradia. I'm working for Volvo since the last 4 years. Currently, I'm a staff engineer. My background is on Android development. I've been doing Android development for the last 10 years-ish, pretty much since the first Android was out. I'm coming from Argentina. You can notice my perfect English. Back in Argentina, I used to teach functional programming in university, some courses. Yeah, I'm not so active on my social media, but it's there. So, yeah, that's me. Now we can finally jump into functional programming and what everyone likes. So yeah, the first, or the topic of the talk was functional thinking is solid, or applying functional thinking into your solutions will lead to solid code base. So what is functional thinking? We could say functional thinking is a process applied to solve a problem in a functional way. Yeah, but that doesn't say much, right? Defining functional thinking using functional, even when it's recursive, which is a functional concept, doesn't help. So let's go one step behind and try to define functional programming. Like every good software engineer, we go to Wikipedia and we find the definition. Functional programming is a programming paradigm where programs are constructed by applying and composing functions. Not only that, but it is a declarative programming paradigm, and in which function definitions are trees of expressions that map values to values, to other values, and they do not, or try not to, change the running state, right? So here we can identify application and composition of functions, declaring expressions that map values to values, and avoid side effects or avoid changing state, right? So, yeah, apply and compose functions, work with declarative expressions, avoid side effects. If we apply this concept, we could say that somehow we are applying functional thinking. Pretty straightforward, right? But what does that really mean on our code base, right? How do we apply this to our solutions, right? So let's start for the first part. What does it mean to compose functions, to solve a problem by composing functions? So mathematical definition of functional composition is basically to use the input, the output of one function as the input to the other function, compose both together in a higher abstract function, and get the expected output, right? That's okay, right? But again, what does it mean on the code base? Do we apply that on our code day by day? So do you want to see an example of it? Yeah, okay. Let's take, for example, our application, right? We have a UI that shows what is the current state of your car. It shows a snapshot of the car. If the car is locked, not, the door is open, if the climatization internal is running, and many other aspects of the car, even the windows and other stuff, right? How do we build this snapshot? We get it from the screen data, right? That we compose or we apply, we map to whatever we show on the screen. On its own, this screen data is built on application level or domain level data. That on its own is built from cloud data that is getting it from the car on the last stance, right? This is not something new. This is quite common on pretty much every cloud-based application out there, right? So we have a clear composition where we have our JSON or representation of the car state from the cloud that we usually map into a domain object that makes sense on our domain layer, that finally we will map on the screen representation of that domain layer that will be shown on the screen. So we can say that for building a car UI for a given car ID, we get the car snapshot that is built from the car state, that is built from the cloud car state. Composition, right? So this is still talking about functions somehow, right? What does it mean now if we jump to a specific Kotlin code, Android code? Well, usually the mobile applications, they follow a similar architecture than this, with maybe different flavors, where we have a view model that will control our UI, and both together define the presentation layer. We'll have a repository or equivalent that will define the domain layer together with the entities. And we will have a API, cloud API, could be a database or a data store that will define the source of the data, right? So if we apply the composition thinking pattern here, what will allow us to do is to start decomposing the whole journey, the whole problem, into step by step. We can start, for example, by the more visual feedback, which is the UI. We can try and build a car view that only receives a car snapshot, that we can mock. We can create our struct if you are using Swift, or our data class on Kotlin. And we can focus only on the part that, given a current snapshot, we need to show the corresponding car on the UI, right? Once we manage to do that, we can move to the next step, which will be to create that car snapshot, right? On our view model, we could either, again, mock a repository or mock the whole car state together, and we can focus on the map to a car snapshot function. Then, once we have the view model providing the car snapshot, we can link together our UI with the view model and make the UI listen to the changes on the view model or update itself whenever the view model changes, right? And finally, we can go to the lower step where on the repository implementation, we can focus on how to map the JSON data into the entity, the domain entity that we are going to work around the application. Yeah, so that's, if we resume, we have on the presentation layer We have the view model that gives us the snapshot that is built from the car state that is built from the cloud car state. So we are applying composition on our daily basis. I'm pretty sure that if you are not functional purely programmers and if you have been working on object-oriented similar patterns like this, you have been using, or maybe some flavors of it. And on my personal subjective opinion, it's quite straightforward what is happening on each layer, what is the responsibility of each of those, right? Bob Esponja, yeah, Bob Esponja. That's Spanish for SpongeBob. Agrees with me. So yeah, functional composition is one big topic of functional programming. Another word that was there was apply functions. And we can as well talk about partial application. What is partial application? A partial application is whenever we have a function that receives 2 or more arguments. And based on that low-level function, we can call it, we want to create a higher level, abstract one of these arguments, and fix that argument to a particular value. So the higher level function doesn't need to know about that argument, right? Question is then, are we using partial application on our code base? Have I used partial application on the pieces of code that I showed before? If we come back to the composition example on the functional-ish way, we only have one argument, right? So somewhere we hide arguments, or maybe we haven't used it at all. Let's see what the Kotlin code what has to say about this, right? So we say that on our UI, we are showing or presenting car snapshot, and we get this car snapshot from the view model. On the view model, we get the car state from the repository. On the repository, we get it from the cloud. Do you see the second argument on each of these steps? When we program on object-oriented, we are sending message to the object, right? The receiver of the message, if we translate the message into a function, we can say that the receiver of the message is an argument of that function, right? On this case, for building a car snapshot, we need to know about the view model that we are going to get it, right? For getting the car state, we need to know about the repository. For getting the car from the cloud, we need to know what is the cloud that we are pinging, right? Yeah, so why is this important, at least to identify? We could then, I lost my pointer, here it is. We could then rewrite our functions to each of them having the 2 arguments that they need, right? And what we are doing in real life or in our code base, now let's take the example of the repository. The way that we apply partial application is by having an implementation class that stores that partial parameter as an internal state of the object, right? This is important because the arguments that we are trying to hide away from more abstract layers are defining the dependencies of our class, right? They are defining what do we need in order to provide the abstraction that we need on the level that we are, in this case on the repository. And then we can provide the car cloud with any dependency injection framework, Hilt or Coin or any other that you prefer, right? So partial application then, what it helps us is to abstract away the implementation details. On our UI, we don't know anything about repository. We know that we have a view model and a car snapshot that we can get from that view model. How do we get it is not a concern of the UI. The same happens for the view model, doesn't know anything about the cloud, and the repository implementation doesn't know anything about the car, if we like. Yeah. So why do we want to use it? To have implementation details, to identify dependencies, and then be able to use dependency injection to provide those dependencies that we just identified. But yeah, partial application and functional composition, they are not the only big concepts on functional programming. Many may argue that the next one is the biggest concept on functional programming, which is the existence of high-order functions, right? So what is a high-order function? In simple words, it's a function that can be used as a parameter or as a field. Very simple words. And why do we want high-order functions? Is to be able to abstract behavior, to be able to construct or compose a function where our high-order functions are argument of that function, and then be able to change the behavior of that final composition without needing to change the implementation of that composition, right? That looks nice, right? So can we apply this on our code base? If we come back to the functional-ish composition here, this is a good composition, but we are hard coding, or we are defining explicitly what are the functions that we are applying, right? So if we use high-order functions, we can abstract away each of these and receive it as a parameter, and then we are able to change the behavior of our, or to extend the behavior of the car snapshot function without needing to change the composition structure per se, right? Again, how this is nice. So how do we bring it into Kotlin? If we take the view model, for example. The view model, we are using partial application to hide the repository from the UI, right? We are using the repository to get the car state, right? So we could move all this dependency to a high-order function, and then our view model doesn't need to even know about a repository. We only need to know that we need a car state, and the responsibility of the view model is to map that car state into a car snapshot. If we talk about object-oriented and clean architecture, there is a concept that we use a lot, which is a use case, usually to not only, but to model abstractions, behavior, sorry. And then we can create a class, a use case class, or an action class, if you want to call it, On Kotlin, we are allowed to use function times as a supertype. And then we can implement our behavior on this function type, right? This is still a bit of boilerplate code. Kotlin goes a step forward and allows us to directly access to the functional reference of the method of the repository. And then we are creating a class, getCarState, a use case class or an action class that is a subclass of a function by the getCarState method on the repository. So we are abstracting away not just the repository, but the whole function call. Then on our dependency injection layer, we could instantiate our view model by passing this use case. Or we could even, if we go back, here we have a functional type. We don't have a use case, right? So we could even go all the way and avoid the whole use case class and directly instantiate our view model with the car state, right? Why would we like to do this? Why having repository is not good enough? One of the principles is interface segregation, right? Which says basically we should not depend on behavior that we are not using. The repository here more likely will have more methods than a single getCarState, right? So to avoid depending on a class that may change for some other reasons that doesn't have anything to do with my personal responsibility as a view model, then we go this way, and then we can, reach that goal. Yeah, so on my eyes at least, this is pretty nice, and it's good to have, right? So next big monster on functional programming is the side effects, or the lack of them. Or at least that's how it's misunderstood, right? Side effects or functional programming on the purest world, it means or tries to avoid side effects and apply on a mathematical way definitions of functions on top of definition of functions. But the reality is that we will always need to write something on a database or show something on the console or on the UI, right? So if we go back to our application, we have a button on our app that we receive a notification that says you forgot to lock your car. So we are far away from the car. We don't want to walk back again. We press the button to lock the car and lock it remotely, right? So that lock action will float all the way till the car. The car itself will lock, will change its state. We have a side effect there. And that new car state that is now locked will go back, and we will show it on the UI. Your car is now locked. You can enjoy your beer quietly. Yeah. Or if you drink water, you can drink water as well. Yeah. So the important thing here is that during this whole journey, both ways, in the middle, we didn't have side effects. We have side effects that happen here on the car. We built a new car state. We send it back. It went through all the steps without state change, sorry. And then we present it on the screen with a new side effect, right? If I can open this, good. So how does this relate with the code? On our UI, we will have a lock button that tells our view model we need to lock the car. Our view model knows the car ID already, tells the repository you need to lock, or we can use the high order function, use case, action, or whatever you want to call it. And we locked. And eventually, the repository will tell our cloud that has to send a lock to the car. On all this step, the side effects happen on the last one. On the way back, whenever the lock succeeds, we publish a new car state. This new car state, or our view model, will be observing or listening on that car state and will map that car state to a car snapshot. And as we have today on our UI, the car snapshot, we are observing on the changes on the car snapshot, and the UI will update as well itself on based on that change, right? On this way back, the side effect happens on the UI, on the last step, again, right? There is something, a big concept that I won't be able to talk today, but if you have heard of it, you may have identified here, which is reactive programming, where we have, or you use a stream of data, and then you react to the changes on that stream. So here our stream will be the car state flow. On Kotlin, we use flow. It's a library or a hierarchy of different that implement the stream. And if you have used RX Java, or if anyone is a React programmer, you may be aware of this technique. But yeah, unfortunately, that topic is not on the scope of this presentation. I only had so limited time, unfortunately. So there is a lot of material out there to check on reactive programming. Just as a small reference on Kotlin, you will use the library flow for it. Another big topic that we touch a bit, but not so much, is about immutability, where basically you define val as your fields on Kotlin, and that will make the language not compile whenever you try to modify your val, right? Another big topic is the separation in between data and behavior, that within the object-oriented community is more and more popular. On Kotlin particularly, we can talk about data classes that doesn't have any method and is the equivalent to a struct on Swift, where we could have all its fields, immutables. And then behavior, we can build our use cases as we saw before. And the latest, not on this topic, on this topic is monadic error handling. As well, a lot of material out there. In Kotlin, already support, the language already supported, just by using result. Monadic error handling is basically, instead of throwing an exception, you return an error that is failure or success is kind of a maybe or a either in functional languages. Yeah, and then you can decide when to handle that error. So, yeah, we presented some concepts on functional programming. We tried to see how they reflected on the code base that we built following them. But the title of the talk was about functional thinking is solid. So what is solid? And how does all this relate to solid? Solid is 5 principles on object-oriented for the ones that haven't heard about it. And it stands for single responsibility principle, which says pretty much an object or a class should only change for one and only one reason. Another way, it should have only one responsibility. So how the functional thinking help us into reaching that single responsibility? As we saw before, the compositional nature and the compositional approach of our solution allow us to focus on one step at a time, solving one problem at a time, on one level of abstraction at a time, right? So that will help us reaching that one thing at a time will be the one responsibility that on that level of abstraction we will be using. The function definition is input, output. Give me an input, I give you an output. You cannot not add more responsibility than that. It's a single responsibility by definition, right? Then when we talk about side effects, because that's the mathematical definition of a function, but then when we will go to code, we can give you an input, we can, from an input we can build an output and give it back, but we do something on the back, right? And that's the side effect that we want to avoid. That's why it's quite important to be totally mindful and conscious about when our code base is doing side effects and try to scope it as much as possible and try to follow a rule that a function, a method, either calculates a value from its input or generates a side effect, but not both. When we do both, we start complicating stuff and funny bugs start happening around the code base. So if we go to, again, the original code base, we have our UI. That responsibility is to grab the car snapshot and present it to the UI. The view model, the responsibility is to build a car snapshot from a car state. And the repository will be publishing or emitting the car states that builds from the cloud. One responsibility on each. The O from solid comes from open-close principle. Software entities, classes, functions, objects, modules should be open for extension, but closed for modification. What does it mean? That whenever you build your piece of code or your piece of software, bless you, you want to be able to extend that piece of software because the problem changes or your application has new requirements or something happened in the way, you want to add functionality, right? But while adding that functionality, you want to do not change the functionality that is already existing and working well and that you don't need to change, right? And this principle is mostly focused on the code base, right? So if you write your code on a way that you can add new behavior without touching the existing source files or source code that was before, then you can ensure that you are adding new functionality and that you are not introducing regression bugs, because the code that was there, you never touch it, right? So how do we get this principle with a functional approach? By abstracting away our use case on the view model, for example, and let's say that the car state, instead of from the repository, we want to get it from a database, or we have a cache, or we have something else, right? We can just change the implementation of the function that we give here, and then we are changing the behavior of view model without changing actually the code that is written for the view model, right? So the high order functions or use cases or actions, together with dependency injection, we need to be able to tell what implementation of the function the view model is using at the time, right? Will allow us to extend without modifying, right? In object-oriented, we use interfaces a lot for this. And a function is an interface that we bring to the limit of single responsibility, right? Another big technique for ensuring this principle that unfortunately wasn't covered is using reactive programming plus immutability, right? The reactive programming, you have one stream, and you can observe on that stream and react to it. So if, for example, let's say we have analytics, we send an event, and we publish an event on the stream. Today, we send those analytics to Google Analytics. Tomorrow, we want to add Firebase. The way that we send those analytics to Google Analytics was by listening or observing on the reactive stream, and then reacting by sending that. From a different piece of code, we can observe on the same stream, and then react by sending to Firebase without touching all the previous existing code, right? List code substitution. This is the L of solid. So what this basically says is that if we are replacing an object or a parameter, an argument, with a subtype of that class, the piece of software should work as expected. We shouldn't break it, right? So what we are saying here is that no matter what application implementation of getCarState we send, view model should still work within its behavior, right? So basically, avoid side effects to avoid unexpected outcomes, or be aware of the side effects that you are introducing on your code. That will be a better wording, right? We could use the Monadic error handling. I don't know if you paid attention here, to encapsulate the exceptional cases. Then the behavior of getCarState is always the same, success or failure, but it doesn't crash because of unexpected exception, right? And we need immutability mostly to help with the side effects, and as well if we are using reactive programming. Interface segregation. So what this principle says, we talk a bit about it, is that your class shouldn't have an extra dependency that is not using, right? that is not needed. The reason for this is that if we change something on the repository, we shouldn't need to recompile this class. We shouldn't need to, a change that is not impacting the explicit use of the repository on the view model shouldn't impact the view model, right? So to avoid that is that we use the higher order functions to bring, to add each dependency that we need from the view model. And finally, dependency inversion. The goal of this principle is mostly to avoid recompilation. The principle says that your code base should depend on abstractions and not on concrete implementations. The background for this principle is that the concrete implementations are likely to change, while the abstractions, if they are good abstractions, they may or should keep stable. If we separate both things, whenever we change something on the concrete implementation, there will be a recompilation need, but the modules or pieces of code that depend on your abstraction, they won't need to recompile because you are still depending on the abstraction that hasn't changed, right? So we get this by the high order functions as well. We use the high order function as our abstraction. The from string to char state is the highest abstraction ever that we can use. And this will never change. So our presentation layer is consuming this, the view model is consuming this abstraction, right? It's invoking it and doing something with the result, but doesn't know anything about what is the particular implementation of that abstraction. Then the data layer, the implementation of the repository, is the one that actually gives the specific implementation for it, right? And all the way, the higher definition, which is a type, will be agnostic. It doesn't know anything about who is using it or who is implementing it. It is just is, right? It exists. Yeah. So with this, I hopefully cover the 5 solid principles. And hopefully I haven't confused you enough. Or maybe I confused you enough so you go and do your own research after this. And let me just end up with some close notes. Object-oriented and functional programming. Back in the days when I was in university, it was kind of a fight in between. What object-oriented is better, applies better to the real world, or functional programming is purer, is mathematics, mathematics is the bigger through. But nowadays, we see that most of the languages allow functional programming techniques, at least, right, or capabilities. And basically, you don't have to do either or, right? You can apply object-oriented to the portions of your code or of your solution that makes sense and is more natural for object-oriented. You can apply functional programming to the other part, right? And you can combine both and get the best of both worlds, right? If you are purely object-oriented, you don't need to go all the way functional programming. You can apply it only on the places that you need it, and you can start with small parts of your code. Maybe you end up liking it, right? It can take some practice. It's not automatic. Mostly if during your whole professional career you've been taught and used to think in objects or in classes and hierarchies, right? But once you master it and you get used to it, at least in my personal experience, it has helped me a lot to structure my line of thinking and keep a common routine, right? One final note is that there is a SpongeBob GIF for everything. Yeah.
Yeah, you made that clear.
Yes. Hopefully, if one thing you got from the talk, you either love or hate SpongeBob today. Yeah. So yeah. Any questions? Thank you.
Here you go.
Yeah, let's see. Is it working? Hope so. So yeah, you made an interesting point of basically looking at different functional programming concepts and the solid principles and kind of seeing them as one and the same in some ways, of different way of looking at the same thing, or I should say FP and object-oriented concepts.
Yeah.
But I want to ask, in one of the examples you gave, it felt like there was a contradiction between them, and maybe I missed something. When you were talking about, so first you had this hiding that one parameter, so partially applied functions.
Yes.
And you put the repository in as the hidden parameter that
Yes.
carries over. And later you showed an example where you were doing, what was the later one? It's hard without everything in front of
On
your
the
head.
cloud. That
Sorry?
the repository goes to the cloud.
No, well, later you were doing the, you got the higher order function
Yes.
and took the get car snapshot from repository, made the assumption that it's a static function, and basically was able to pass that as a function to a higher order function.
Yes.
My question is, when you did that, you lost the repository as a partially applied parameter, and you can no longer depend on the repository as a data, as an object.
Yeah. We went even one level higher of abstraction. We not only hide the repository from the UI, now we hide it even from the view model.
Well, no, you don't hide it. You prove that you never needed it.
Yeah.
So why did you put it in why did you need to pass it in as a partially applied thing from the beginning?
Because at some point you will need to access to that repository or to the cloud unless you go functional all the way, right?
Yeah, but then your second example can't be possible because you're directly connecting to that get snapshot function without having a repository object.
Yeah, but the one that is partially applying the repository is the dependency injection layer when we instantiate the view model by sending the repository or the use case that implements that class. Let me see if I can exit the, okay. Let's try to find it out. So I think that it was this
Right,
slide,
so here.
So yeah, we move this one away, right? And then we remove the need of a repository from the view model, right? But at some point, someone needs to implement this function, right? And this function still receives one string, the car ID, and gives back a car state. But the way that you implemented, you need to go through the repository to be able to get that car state. And here is where the partial application happens. You either hide it on the use case implementation, or you hide it on the dependency injection layer when you send it here.
So maybe I'm not familiar with Kotlin syntax here, because to me that looked like giving a pointer to a static function.
No.
Get car state
Yeah,
in the repository.
exactly.
And then
Maybe
saying,
that's your confusion. This is an object, right? I wasn't totally clear here by saying on the dependency injection layer, you will get the repository from the dependency injection, right? Because you need a repository. And then this is a pointer to the function of that object, of that repository.
Okay, then that makes more sense. Thanks.
Okay, yeah, don't worry.
Thanks. Yeah. I'll turn it off. Is there any more questions? Oh, yeah, one in the back. I'll run.
Yeah, thank you for your presentation. Do you use Kotlin on the server side at Volvo or only for mobile development?
That's a complicated answer. Some servers use Kotlin, some use other technologies. Yeah, most of them don't. But yeah.
So is there any kind of movement or activity of like moving some older implementation from Java over to Kotlin or some stuff like that?
There are some initiatives within Volvo. The technologies on the server side is, let's say that we have way too many different servers. And we are using C# for some of the stack. We are using Java for some of the stack. And yeah, Kotlin is something that is interoperable with Java. So there have been some proof of concept with the Kotlin, but there is already expertise on the other technologies.
Got it, thank you.
Yeah.
Any more questions? No? Thank you very much, Juan.
Thank you.
Thank you very much. Yeah, please disconnect that. And we'll get our next presenter up, Reda. And take your time and go and grab some pizza or some beverages while we connect this laptop. No, almost done. Yeah. Yeah. Yeah, sure.
You're sitting there if you feel it.
No, it's good. I think it's good. Let's see. I can take it. No, it says. Yeah.
Oops, I just went to the last one.
Yeah.
I hate it when that happens, but it's okay.
Yes, to everyone in the live stream, we'll take like 5 minutes. So everyone can take some air and come back. Yes, we can. Let's get started, people. We're starting again.
Okay.
Yeah. Let's start. Yeah. Maybe. I'll just give you a short intro.
Yeah, thanks.
Yes, then thanks. Everyone has found some pizzas and some more snacks. That's great. Then we'll start with our second presentation. Reda, welcome on stage.
Thank you, thank you. Good evening, everyone. I hope we're going to go through this together with as much energy as we can. I know it's the end of the day, and it gets usually hard around this time, but I'm going to try to keep it swift. You get it? There we go. Before I start, a couple of things. I'm going to call out Juan about something he said earlier. OOP and functional programming cannot be best friends. Just let's get this out of the way, and then I'll continue. I'm kidding, by the way. But let's do this. Apparently, I have to have a slide about my... What's that? Yeah, let's do this. This is the typical slide I talk about myself. I'll try to keep it super short. I've been the professional developer for about 15 years. Actually, it's funny. First programming language I ever used was ActionScript, and it was an object-oriented programming, and actually was the inspiration that later on helped people like build HyperCard and stuff like that. There was a lot of ideas from there. And then I moved to JavaScript at some point, but I didn't like it much. And then I think around 2010, I started learning Objective-C. And I was like, wow, this is amazing. And then I did a bit of Ruby as well at some point. And since 2014, I've been doing only Swift and some JavaScript as well, but mostly Swift. Yes, these days I'm doing a lot of Swift UI, which is Apple's sort of like the declarative UI framework for iOS, Mac, all of that. I'm also working for Circle, which is a company based in the US, and I'm doing iOS there, and working on their iOS project. I've also done a good amount of server-side Swift since 3 years ago. And yeah, I've been really enjoying using Swift across the board, server and client. On the web, of course, we still use JavaScript, but that's the only missing piece. You can find my more stuff. I don't update my website as much as I used to, but it's myname.com, basically. And I'm Kaishin on Twitter. I'm not going to get into the story of why I have that nickname, but it's a nickname I had on every social media. If you Google that, you'll find me on GitHub and all of that. All right, let's get going. And by the way, you won't see any SpongeBob here, but you will see a lot of turtles. And I will prove that you can do as much with turtles as with SpongeBob. So, Swift. But quick show of hands. How many of you have written at least one single line of Swift? Wow, actually. I see one hand there, but I don't see the person. I just see the hand. Thank you. So quick recap of what Swift is. And so this presentation, basically, I'm going to talk a bit about Swift and then about functional composition. A lot of this stuff Juan has already covered, to be honest. So I feel like I could drop the second part entirely. But we'll do it. I think it's a different take on some aspects. Swift was released in 2014, 1.0, and 2.0 was open source in 2015. I happened to be at WWDC that year, and I talked to Chris Latner, the guy who actually made Swift, and it was amazing because when you hear about these things, like, I want to talk to the person who made this thing and ask them questions. And I was talking to a random guy at a meetup about Swift. And then all of a sudden, I see Chris Latner butting into the conversation and saying something like, I agree with you. And I was like, no, this can't be. That was my programming career highlight. Swift works on Mac, Linux starting 2.2, and Windows starting 5.3. It supports OOP and FP, of course, and I put, so POP is, I've seen this, it's not a common acronym, but people use it for protocol-oriented programming, which is basically just using interfaces instead of just classes. But yeah, I just put it there because I see a lot of, especially like Swift developers use protocols or interfaces quite a lot. It's statically typed, and it interrupts with C, Objective-C, Python, and JS via JS context, and C++ is actually work in progress. They're planning to make it a lot more nicer to work with Swift and C++ together. I'm looking forward to that, especially for game development. Where can you use Swift today? Well, obviously, Apple platforms. Server side, it's actually getting some traction there as well, and I have shipped a couple of projects there that are in production. Serverless as well. There's an official AWS Lambda support for Swift. It's been there, I think, for a year and a half or so. Cross-platform CLI tools, basically anything really that's not GUI related, you can use Swift for, and you can also use it for GUI things, but it's a bit iffy there because the APIs are not translated. Webassembly, this one actually I'm super excited about. Swift WASMs, like right now it's not really, changes are not upstream Swift, so you have to use a fork of Swift, but when this is gonna like be really nice to use and be upstream, I think I'm gonna use the hell out of it because I don't really like writing that much JavaScript these days. Some notable Swift features, immutable value types, and Juan earlier talked about similar, actually Swift and Kotlin, they share a ton similar, like my last project, I was looking at both and they share a ton of things. Obviously they have differences as well. Mutable reference types, of course, because it interrupts with Objective-C, so it needs to have mutability. First class functions and higher order functions, I'm going to talk about those briefly, and in the earlier presentation it was already talked about basically higher order functions. It supports generics, protocols, type extensions, blah, blah, blah. I'm not going to talk about all of this because there's a lot. Pointer APIs, async await, yeah, what have you. Actually, the last two could be interesting from a functional programming point of view because first, for the operator overloads and custom operators, if you really like some functional programming operators, you can use them in Swift. And like variadic parameters, there's just a nice thing to have when you don't know how many parameters you will get. So always nice to have. Emoji support. This one actually, I don't really think it matters, but they made a big deal out of it initially. So that's actually a valid function, turtle and parentheses, that's valid code basically. And you can, I've seen a couple of people doing it as a joke, but no, you shouldn't do that. Okay. Sorry. So let's talk about the topic. I'm going to talk about functional composition in Swift, but I'm going to try to focus on one aspect that I think a lot of people don't focus about, or talk about rather, is when you're designing an API for other people to use, a lot of people just go I'm going to use protocols, or you can subclass this thing. And like as an API author, I haven't seen enough good use cases of functional programming as an API, like when you're, let's say, even within your team or as an open source project. So I'm going to try to focus especially on those aspects, but obviously, like, there's so many things we can use functional programming for. Functions in Swift. If you have never looked at a line of Swift, and I think a few of you haven't written Swift before, yeah. So basically, this is the syntax, func, and the name of the function, parentheses, and then curly braces. Or you can define it as a value. So your function equal curly braces, and it's a closure syntax. So basically, it's kind of a lambda, but in reality, it's not because it has a name in this case, which is grays. And both of these are called just by the name and parentheses. This is super basic, but I just wanted to cover it because we start everything from first principles. So every function has a type, and I think Juan also talked about that earlier. Parameter type and then the return type. I think most of you here are familiar with this concept. Interesting because I have given variations of this talk before, and some people who haven't done much functional programming, it was like, oh, really? Functions had a type. I never thought about it that way. But yeah, I mean, functions are just a type, just like any other type. So yeah, in this case, the first one takes nothing, returns nothing. So we have the the parentheses and then void. The second one takes two ints and adds them together. So int, or integer, that's the type for it in Swift. There was a slide earlier about higher order functions. I'm just going to quickly go over it. And also first class functions, which is just like another concept. So functions in Swift they have all the standard operations available to all other types. So that's why we call them first class functions. You can assign them, pass them around. You can do a bunch of things. You can do whatever you can do to an integer, you can do it to a function. So high order functions, that includes also passing functions as arguments. And I will add also returning them as return values from other functions. So that way, functions just become just literally like any other type. These are super important things to have in a language for it to support functional programming. Like the languages I've used, I think besides JavaScript and Swift, Ruby to some degree didn't have these concepts, but like Objective-C had none of this. And the one I started learning programming with ActionScript had also none of this, as far as I recall. It's been a long time ago. So functions as values, I will be super fast with this. In Swift, this is more of a Swift technicality, but you can have let to make it a constant or var to make it a variable. And functions have the same semantics. If you define it as a let, you can't change it. That's it. That's the entire thing that this slide is trying to say. Functions and parameters, we have seen examples a while ago. So let's say we have a function called graze and we have a function called do something that takes another function that does nothing and actually returns nothing. Just for the sake of this example, I kept it simple. So you can just pass graze to the do something function. And by the way, this graze is basically, I'm talking about the turtle in case you missed that. We're still talking about turtles here while talking about Swift. Return values, same. You can return a function. In this case, I create a function that can generate a bunch of functions. I mean, this is something pretty straightforward if you have done a good amount of functional programming. But for some people, when they see this, they say, oh, wow, you can generate functions like that. Like, yeah, you can. So like, we have this function called drop. It basically just drops the last n number of string characters from a string. And you can see that the first one, it just calls it without argument. And here there's actually some nice things in Swift that other languages, of course, support, but you can have default arguments. So like in this case, the default is 1 for the count. So when I call drop last without any arguments, it just picks 1. If I call it with count 2, then it will drop the last 2. So basically, I generated 3 functions just from one function. And while this example might be a bit moot because it doesn't do much, this is a lot more powerful when you combine it with partial application that we have seen earlier, and also you apply it with a bit more complex domains, let's say. And we're going to look at one good domain that we're going to apply some of this to. So function composition. So what is function composition? Again, if you have been paying attention in the first presentation, you already know what this is. But it's a series of functions where each function receives input, does some additional computation, and then hands the output to the next one. That's it. Like, super simple. I think you can literally, I can show this slide to anyone who's never done any programming. They should understand this, or they would understand this rather. So let's go back to the last 3 functions I defined: drop last, drop 2 last, drop 10 last. We can basically compose them by creating another function called drop 13 last, and then just one function calls the next until you give it the value. And you can use this by just calling drop 13 last, and then give it some string. The slow green turtle jumps not, and it will remove the last 13 characters. This is just to show an example of, in practice, how does composition look like. It looks like this usually, but let's continue. I just wanted to put that anyway. Like, I had the image. I looked for the slide, not the other way around. Point free. This is actually something that a lot of people might have heard of, but not be familiar with. But like we call the point free syntax or tacit programming, if you want to be more academically correct. It's when a function is achieved solely through composition. Basically, you don't pass any explicit parameters to it. And the first example is that the one I showed earlier, I cheated a bit. It's not pointer free, and it's actually imperative. The second one you can see the declarative point-free version. So it's just the operating last is compose these three, done. There's no information about what arguments it takes, etc. Whereas the first one is kind of straddling, it's in between. There's composition, but more like you're calling it manually. Each function is calling the next. Whereas the other one is like syntactically, it's much easier to read because you just read compose this, this, and this. It's just even easier to reason about. Okay, so now theory is nice and everything, but I want to drive my point with an example. And this example is not something I came up with to drive the example. It's actually code that I took from 3 projects that I've already shipped this in production since, I think, 2.5 years ago. And this is something battle tested. I've used it in many teams, many setups, always works pretty nice, and people usually really like working with it. I work recently a lot as a mobile developer, and one thing we do is we talk to the cloud all the time. That's actually what mobile apps are these days. It's just, basically nice interface for JSON, basically. You get a bunch of information from a server and you show it. So we build a lot of REST API clients. And this is the same for the web. If you have a React app or what have you, you always have to build these like logic to talk to a server, get response, do something with it. So we're going to use functional composition to build an API. So we're going to build an API to create an API. So basically, the building blocks of how to build an API, a REST API client. Briefly, just to make sure that we're on the same page here, this API client will have a list of RESTful resources, endpoints, what we typically call just an endpoint. And basically, we'll call some networking interface, which is a side effect, and we'll return. I'm not going to talk about side effects. I'm not going to talk about network because these are a bit beside the topic of the presentation. But again, in the first presentation, we got a good introduction to side effects and why they're necessary. But this thing we're going to talk about, we're going to focus on the creation of this API. So what does calling a REST API endpoint typically involve? Basically, you have to typically you have to do the same things over and over, like regardless of the app, the context. First thing, you have to create some client-side representation of the API endpoint. So like if you have an endpoint that does X, your app need to know about, you need to represent an abstraction of that endpoint. Second, you need to add logic to transform input data into some platform-specific request objects. So like in JavaScript, it could be fetch API. In Swift or iOS, URL request. Basically, whatever thing you're using, you need to end up with some object that you call, or some configuration, rather. So these 2 tasks are involved in every aspect. I removed 2 more because I had them before, but I removed them because they're mostly side effects, which is call the endpoint, get back a response, parse it, get the object back. But these 2, like it's hard to reason purely in a functional way because it's by nature a side effect. You're calling something remote and getting back a resource. Still, you can make it nicer to work with in a functional setup, but again, not the topic of this presentation. Rewinding, step 1. So we need to create a client-side representation of the endpoint. Turns out that endpoints, they're also just input and outputs, basically a function. So the input data will be sent with the request, and then the output will be expected from the response. So this part, let's take an example. Let's say we have an endpoint that you can give it an ID, you get back a turtle, right? This endpoint, I could, in the client side, I could define it as get turtle with ID, and returns the object that we want. Now, before I continue with this, now the goal here is that we'll try to implement this, right? This is our goal. This is our end game. Like when we get here, the presentation is over. Actually, I have 2 more endpoints I'm gonna show just to give some good comparison of how this can work. But before we get there, just quickly, this is the request object I'm gonna be using. This is kind of not the production version. I removed a ton of stuff, but these 5 things are almost always there. So basically you have to define the method, post, get, etc. The path, so basically the URL, all the slash something. Small note, that custom string convertible is not as scary as it looks. It's just a protocol in Swift that any type could basically conform to, and you can have non-string types also be passed to that thing, and they know how to basically transform into a string. So you just get some nice syntactic sugar there, basically. It could be an array of strings as well. The query items for the URL queries, and the headers, of course, we always need those, and some data for the body. And it's a question mark means optional, like we could have also no data. So this is enough to make technically any request. Obviously, if it's REST, we're not talking about other kinds of a type of APIs, or sorry, of technologies. So the get_turtle request, it gets a UID and returns a, actually it should be return a turtle there, not a request. But that aside, we come back to, so this is the function that we need to define, right? What am I going to do inside this function? So one way, this is the imperative way that I have been doing since a long time ago. You create a new request object, right? You configure it by setting its methods. So method get, sorry, its properties, and then path is turtle/id. And by the way, that little syntax there is just for string interpolation. And so you return the request. This is the typical way I have done this personally for a very long time. But there's actually kind of a different way to look at this, because if you look at these single lines here, each one of them is some transformation. Like when you set the method to get, you're basically saying, take this request and make it a get request. Well, if we look at this from a slightly different angle, you can see this shape. This is pseudocode, by the way, but just to give you an idea of what we're looking at. If we compose three things that all are functions from request to another request, so basically request transforms, then we could actually define this endpoint in a completely point-free way, basically without having any sort of, I mean, not 100%, we still have to pass .id, but even that can be sort of removed using partial application. But I'm not going to talk about that for today. So yes, this is what we want to achieve. So one nice thing I like about Swift is type aliases. And those of you who have done Swift here, they know that you won't find a code base without a type alias. Everyone loves them. You can basically say, well, this type is basically, we're going to just alias it to request transform. And so the get becomes a request transform, which is a function that takes a request and returns a request. And what you do there is basically just pluck. I just took the part where I set the method, and I just dropped everything else. So basically, the syntax there is create a copy. So that line that says transform.quest, remember, this is immutable. Swift values are always immutable. So you can't just say, oh, take this request and just make it a get request. You have to create a copy, modify the copy, return the copy. That's the dance I'm doing there. Obviously, I could cheat. I could make actually request a variable, but I really don't like that sort of like mutation. I just don't mind creating copies. This stuff is cheap, and our devices are so powerful these days that this is nothing. Like this is not something we should be concerned about. By the way, Apple picked a terrible name for this language because whenever I Google something like Swift lenses, this is what I get. Google just suggests things related to Taylor Swift all the time. Actually, I didn't really know much about Taylor Swift until I became a Swift developer. And now I know everything, like what dresses she wears, what concerts she has been to. This slide is not even a lie. I was actually Googling Swift lenses because I wanted an open source library for lenses. I got this. It's like, come on. Composition, I think it's okay. But I don't know what you're going to get. Don't click images. You get some weird stuff. Swift, terrible name. But why did I put this slide here? Because actually I wanted to show an example with lenses, because those of you who have been doing a good amount of functional programming know that you can do this with called a lens. Basically, it's a way to make an immutable thing sort of mutable. Not exactly, but it's a tool in the functional programming toolbox, and you can find open source or implement your own. It's not that hard. And so if I do that, then the get becomes as simple as method length.set, and then get. Post becomes method length set post. And then I can remove all this. Should have put that slide in there. All this boilerplate, like line 1 to 5, could go away, and things becomes a lot easier to follow and read. Obviously, you don't have to do this, but it's a nice to have. Then, what do I need? I need now to define functions to modify every aspect of the request. So it could modify the path. In this case, it just adds one extra fragment. So like if we have /turtle / something Swift, then you have to call this twice, basically. I also have variations that add entire like URLs, but this is the beauty of composition. You can compose this into something that returns more path objects. So instead, let's say I have to call this turtle's path many times in this API. Well, I can just basically this is already like I'm creating a function from a function. I just call the path function, but with the turtle's path segment. And now turtle's path is a specialized version of this function that works exactly with this path. And I can reuse this as many times as I want. I don't have to type the turtle's path every time I need that. The open-close principle, this is actually a good example of it, where you can extend this thing, but you can't modify the path thing, but you can extend it. And if you're making an API, that should be your #1 goal, how to allow others to extend your work while not needing to actually go on subclass or do this or all of these like things that typically they end up with a lot more complicated code, hard to test, etc. So same for ID. I'm going to go a bit faster here because what I'm doing is mechanical work. So just create lenses, create definitions for each thing. So here it's a function that just appends the ID. That's it. So in this case, adds a path with that specific UUID as string. And so now that I have all these things, I need to compose them. Sadly, or I'm not sure actually sadly or for the good thing, but Swift doesn't come with a built-in compose operator. I don't think a lot of languages do, to be honest. I mean, if you put aside Haskell or those that are built around functional programming. So you have to define your own, and it's not that hard to define, especially, you can make it generic, of course, in this case, like using these, although it's not even generic. This one, I'm composing 3 functions. And either you can use compose or pipe, depending on the direction you're composing. So the first one, I go, so the first parameter is called last, whereas the second one is the other way around. Honestly, the name in here doesn't matter that much. You could call it whatever you feel like. You will eventually get someone who's like, yeah, well, that's a pipe, not a compose. But honestly, like for me, what matters is basically a way to compose these. And interestingly, for this API, I use pipe a lot more because the path order matters. So I can't just call functions in any order. Like if I'm going to do turtle / something, I need to apply this, like append turtles first, then append something. I can't append something, then turtles. So you have to be a bit careful about order of composition in that sense. Obviously, you can also get around that, but let's not do that here. Okay, now I have everything I need. By the way, this is more of this slide. You see that I am actually specifically saying, oh, there are 3 functions, but this is not smart because you might need 4 or 1 or, no, not 1. You're not going to compose 1. You need 2 or more. So you can also use variadics here and say, just take any number of transforms and just call them like a so basically we're reducing that, and every time we're calling the next transform, it's recursive. This works if you're not using generics. If you're using generics, Swift does not support variadics. So you can't have a list of variadic and generic parameters because it's statically typed. It needs to know every type you're going to pass to it when it, like, when you're compiling. So, but in this case, I know I'm only transforming requests. So I actually don't need generics here. This is completely fine. It works great. We can go with this. Now I have everything. Now I can actually define the endpoint. So the endpoint here is, well, I'm going to pipe the get function that takes a request, makes it get turtle's path and ID parameter ID. And now I defined this endpoint just by composing 3 functions together. There's literally no like assignments or anything going on here. one small sort of bracket sort of aside. I have, like 5 years ago, I was working at a company where we did use functional programming quite a bit in our projects. And we introduced custom operators. And that's okay if that's your thing, you like custom operators. But since then, I've become really careful about introducing these, because if you're building a code base that more people that are less familiar with functional programming will use, they might not be able to understand it. But this is actually valid Swift code, so I can actually just define an infix operator, and I can actually call the get turtles path ID parameter like that, and it works. And you can define whatever like symbols you want and all of that. You have all the tools. But these days, I'm more like, I'm just going to call it pipe or compose and be done with this. It's also like the language doesn't really support these things when it comes to right-clicking, as we call, like basically trying to see the type of something. When you right-click some of these symbols, you don't get a good overview. The compiler just sometimes just doesn't really seem to sort of follow. But I think it got better since last time I tried this. To sort of kind of wrap this up, I'm just going to show two more endpoints and see like how this composition, how can we take it even further. So I worked on the first one, right? Let's suppose we have two more. One that we can create a turtle. It's a post request to the slash turtles, and it requires authentication. So the first two require authentication. The last one is a sign-in request, and it doesn't require authentication because that's how we get the tokens. And it takes credentials, and then and you can see here that there's some things that are common between every two endpoints here. If you take every two, you'll find something common. So this is a typical case in a lot of programming problems where you have things that are kind of similar, but not quite, and you find pairs that are similar in some way, but pairs that are similar in a different way. And this is where I honestly struggle to find any other solution than to use functional composition. I tried a lot of things before, and they always feel like, yeah, but I'm repeating this here, or I'm doing this twice. So in this one, we're going to just quickly look at the type signatures. I love doing this. Whenever I'm working on something, I just go to a text file, and I just write the type signatures of the things I need to work with, and I start working from there, basically. And these are three functions. Again, if you remember, request transform is just another function. So in case you forgot, that's not a type on its own. It's just an alias. So the first one takes a UID and a token. Now I added a token because authentication. I mean, you will never work on a project without authentication, in my experience at least. Like I've never been involved one that didn't have tokens or something of that kind. The second one also takes a token, and it takes an admin key. So now we have more things to work with. And the last one just takes credentials. So how can we make these three sort of be composed? I think the idea here is, I was trying to say since a while ago, is that you can take those configuration steps that you do over and over and just encapsulate them into a function. And then there you go, you have that reusable thing. And I showed a couple of examples with the turtle's path, but I'm going to show some more here. And these are common cases where I found I'm always extracting in every project, attaching auth headers, setting admin keys, and any header basically that you need to set. Setting method to post with the correct content type. Like you always have to do like, it's post, but also content type JSON. It's like, it becomes repetitive, and it's the same thing. And there's so many more. But so first thing we need to do is we define a higher order function that allows us to add a single header. In this case, because I didn't do it a while ago, so here it is. It takes key value and just it sets them. And then we can define another function that uses the header function, but this time this one is specialized in attaching a token. And since authentication is a static thing that we're always going to have, so I just pass it there as a string, and then I do interpolation to grab the token in. So now we created a new transform from an existing transform, and in this case, authentication. All good. Now, I need to update my two other requests, so I need to add that line. You can see it right there, authenticate token, the first one after the pipe. And the reason is before I didn't have it, but now I realize, oh, I need a token. So I need to do this. So there it is. And by the way, I also added token to the request function, the signature, because I need that token. Like, again, if we do pure functions, there's no one who will tell us what the token is if you don't pass it. I have seen obviously code bases that don't do this. They use a singleton and they grab the token from somewhere. Don't do that, because then this function becomes like it knows too much about the system around it. Just pass whatever this function needs, let it do the work. Query items, I'm not going to spend time on this. So this is the post, the second one. No, sorry, this is the get. This is the post. So the post one also becomes pipe-in authenticated post, turtles path, admin key header, and JSON content type. You can compare these two just to see what's similar, what's not. And you can already see something here that needs to be refined. If someone shows up to me with this, I'm going to say, we're going to pass that token to every request. That's a bit tedious. Let's not do that. So this is the third one, and it doesn't need that. So it's kind of, this one is kind of good. This one, you can give it the green check mark of code review. This one is fine. The other two, no, because we can't be passing authenticated token to every request. It becomes tedious. So this is where we talk about the extent, like making extensible APIs. So far with this API, we were trying to just follow the steps, but then we reached a point where like there's a lot of, this code is not dry, like it's repeating things. And with functional composition, we can at any point interject and actually change behavior because it's just functions. So you can at any point say compose more functions or things like that. And I'm going to show here what we can do in this specific case to not repeat the token every time. So I'm going to take a step back, let's say, or like a step forward rather, like jump into the send method. And the send is basically, this is the side effect. It's sending the request. Typically in any code base I've seen, you give it a request, right? A request object. And then you do some magic and you expect some data back. That's the signature up there. I think this approach, while it works, it kind of beats the purpose of functional composition because you're giving it a value that's already ready to be used. How about we don't give it the request? We give it the recipe to make the request. And the recipe is basically just a request transform. Like, here is a recipe to make a request. And please make that request yourself and send it. And this small change, it might seem like trivial. It's like, yeah, I mean, no difference because this one at the end, you're just going to give it a new request and it's going to modify it. But what this actually ends up allowing is quite different because the first one, you can't, once you have that, you can't do anything unless you modify it. Again, open close principle. You have to modify the first one to add the token. So you have to modify the request itself before sending it to the first method. On the second, you don't have to modify the send method itself. All you have to do is create another method that comes between send and whatever thing you did before. And that method would inject the token the way we want. And to be more explicit about what I'm trying to say here, this is what I was saying. So just to give a bit of context, let's say this is the API client object. This one is more data side of things. In it keeps track of a token, a host, like the root URL, and a decoder. You can ignore that one. This is for JSON decoding in Swift because we need that. It's not like in JavaScript where JSON is native. So if we extend this client by defining the send method that I was showing earlier, what it can do is, well, you give it a request transform, and it creates so basically here what we're doing is just we're creating a new request with the transform applied. So in Swift you can skip types if the context is clear enough. So in this case, this init is referring to the request object that I've showed quite a while ago. But what we can do then is define another method called send authenticated, and you give it the same request transform that we give it here. The only difference is that this one have access to the token. So what it can do is it basically composes the original request transform and the authenticated transform. So basically it just injects it there. And now, as a user of this API, you have the choice. You can call this send if you don't want authentication, or you can call send authenticated if you want authentication. Even better, if other people in other teams are using this API, they can define their own send method and like call it send authenticated to, and they attach 2 tokens because one wasn't enough for the security team. So But what this means is that they can extend without touching even like the core. They won't even have to touch this one. They just extend it, just add more by adding. It's additive basically. So with that, we can actually remove token from all our functions, just keep the transform. And actually, I forgot to remove this, or did I? Oh no, this shouldn't be here, this end token, because basically we just need the data, turtle, admin key, and ID and properties. These tokens are not needed anymore because they're going to be injected at a later stage, not now. And this thing doesn't even need to care about token or authentication. Obviously, you can have a different opinion, and you can say, no, I want to pass it here, but that's also fine. You can pass it here, and when you call it, just don't call send authenticated, call the other send, which won't inject the authentication. Boom. It's up to you. Like, honestly, it's up to the developer to decide what each endpoints want, not even like the entire project. And so, one last thing. I get this question a lot. I actually taught some aspects of this in a class, I think a year and a half ago or 2 years ago. And one question actually that comes up is, what if we have some conditional, like I want to compose something, but only if, obviously there's ways to do this, but one of my preferred options is to have an identity transform where it just returns the same request. And basically you can, when you check for, this is a ternary operator in Swift, when you check, for instance, do I get this turtle as admin? If yes, then I want to attach the admin header. So basically here we're just composing this function, or otherwise we compose with the identity function, which has no effect. You can do it like this. You can do if else. That's also fine by me. But this, when I have long series of compose functions, it becomes a bit hard to repeat all of that and remove one thing. So I just, throw the identity there. It should be fine. I don't think it has, last time I checked, it has no performance cost because the compiler actually abstracts it away. So it's just like, this function is doing nothing, remove it. So when you actually code compiles this as if it doesn't exist, or rather, like it will, when we'll compile this one, it will compile the path within it. So you won't have any effect because it will always skip the if part, or the if instruction in the machine code. So it won't have much of a performance cost. And to kind of wrap this up, just show some actual, some things that I'm using like a lot with these, like caching policy, for instance. Timeout intervals. There's so many transforms I'm using. API key headers. This is also pretty common. Pagination queries. Like if you have a lot of paginated responses, ton of them, it's really tedious to keep every time for every request like saying, oh, I expect a page and it has this. So you can, with this, you can define a pagination sort of transform that takes any type. So it would be generic, and then basically transforms it into a page, or vice versa, depending on what you're trying to do. And then you can go to any request and say, also, I want this to be paginated, or expect paginated data, and boom, you got it. It's one line, basically. You add it, and then it becomes paginated. So why is this? Why do we care about any of this? I think, personally, what I really like about this is that it gives a lot of freedom compared to other approaches. So I've used both object-oriented and interface-oriented or protocol-oriented. Those restrict you quite a bit. Like you have to do things in specific places, specific order. With this, you decide where and when to define these transforms. It could be inline. It could be global scope. It could be only in one specific test or function, or basically you decide. And so this on-the-fly and in place are very important for this flexibility aspect of it. And of course, you end up with highly composable APIs because you can just build on top of that. I think this, I'm not going to talk about this because we heard about it a bit in the first presentation, and I talked a bit more about it. But basically being able to extend without modifying, like handling special cases, testing, mocking, it's always easier with this. And so because these are pure functions, they're safer and more predictable, easier to test and mock, and more composable. And I always like to think of these like small Lego pieces that you put together. And it's insane the amount of applications that you can use this for. I picked the API because actually that's the one I use quite a bit. But actually there's way more that I have tried and was impressed by the outcome. Basically these days, whenever I see builder pattern, factories, I immediately think of functional composition. So like whenever you see config let config do something and set this on the config. You see that config in 10 lines, functional composition. That shouldn't even be there. This is what I was talking about. You see it in network requests, URL paths, a lot of things. This is actually pretty amazing because drawing as a thing, like drawing anything, typically you think about it as it's an imperative operation. You just say, go to this point, or like let's say 2D drawing, not 3D. But if you think about it from a functional point of view, you can actually define the entire drawing in a function and then just pass it something that would have a side effect. So it could be it a canvas or a starting point or whatever. And boom, you have the drawing. And then you can just change a thing in the initial thing, and then the entire drawing changes. This one, I wanted actually to talk about drawing, but I realized that not a lot of people draw 2D in their day-to-day job. So I felt like, yeah, I think API is more relatable, but this is actually an area that I'm most excited about, is like functional 2D drawing. And this is not something new. This is actually super old. There was this thing. You will, like, if you have been using the turtle reference, but actually there's this turtle thing about drawing, and some people are nodding, so they know what I'm talking about. And that thing actually is kind of very similar to this, where instead of it's saying exactly how the drawing should be done, you basically describe it. It's like, oh, you go 20 pixels up, and then it's hard to explain that way, but it's when you use functions for that, you can compose things in a beautiful way. So for instance, a square becomes just 4 functions that draw a line, but each one with a different direction, basically. This one also is one that's gaining a lot of popularity these days, but like app state management. You can find a lot of use cases for this. Like on the web, of course, if you look at anything like React, Flux, Elm, I think all of these borrow a lot from this. But on mobile, recently, there's also kind of a renaissance of this, like both with Swift UI and also Jetpack Compose on Android. And you can find examples of unidirectional data flows. On iOS, the most popular one that we use these days is called the composable architecture. It's like TCA, but there are any others. You can build your own as well, as long as you have a clear idea of what you want to achieve. And on Android, you would find few of them. And on the web also, there's like no shortage of these. And for app state management, it works really nice because then we got some examples a while ago, and that could be expanded to basically any aspect other that's not side effects. And side effects, they're not even that scary because with this approach, you always leave side effects last. So you do your functional things and all the awesome stuff, and then in the end, you just say, well, whatever thing, draw this or send this network request or write to the database, and I don't care what you look like. Like, I don't even know who you are. Just do your work, tell me when it's done. It's beautiful, it works. Styling user interfaces, I was just talking about that. So yeah, with this, my talk comes to an end. Thank you for listening this late in the day. You can find the ideas of this REST client on my GitHub, Kaishin/REST client. I didn't push everything, but the overall ideas are there, and it's actually functioning. That one I have on GitHub, it just doesn't have all the bells and whistles. And I think I'm done, and if there are any questions, I'll take them.
Great. Do we have any questions? Yeah. Run down with them.
Don't be distracted by the chicken.
Yeah.
So you promised to tell us a story about your nickname origin.
What's that? Say that again?
You promised us to tell a story about your nickname origin.
Oh, my nickname origin. Okay, so oh my God, I didn't expect I'm going to get a question about that. Yeah, so this nickname, I had it when I was studying in Japan. And I think one reason I got this nickname is because so I have to, in Chinese characters, it means vanguard, heart. So Kai is vanguard. And I think the reason I got it was I used the nickname in Counter-Strike a lot. So yeah, that's how I got it. And then it stuck. And actually, I had an anecdote. I once booked a hotel in the US. I didn't book it, but someone else booked it for me. And they wrote the name Kaishin, because they know me as Kaishin, right? And I go to the hotel and say, all right, so we need to check you in. What's your name? I say, Reda. And they say, sorry, we don't have this name. I said, are you sure? Like, I flew pretty far to get to this hotel. And I was like, okay, let me check. We have a booking for Kaishin. Is that you? I said, yes. Can we see your passport? Yes. It's not Kaishin. You're not going to get this room tonight. I was like, well, sorry. It's not. But yeah, that's the story. It's nothing really crazy. I think it's more interesting when you look at the characters that are used to write it, because I used to write it wrong and someone corrected me and I started writing it right. So in kanji, like Japanese characters, or Chinese really, but yep. Yes.
It's working?
Yeah,
Yeah.
it's one.
It was a nice presentation with the composition for defining the REST API.
Thank you.
My question there is how, or if you had some inspiration from DSL,
Mhm.
domain specific languages.
Yeah. Yes, very. Actually, it's interesting because this, when you end up with that thing, you look at it, you think it's a DSL, but in reality, it's just functions. And Swift later got proper DSL support with function build. They call them result builders nowadays. So you can actually define complete DSLs in Swift. Personally, I don't see the point because I think functions do the job just right. I don't need to define a result builder and define a syntax within a language that's different from the actual language. But yeah, there's definitely a big chunk of my inspiration for this was actually looking at other DSLs and trying to imitate them basically, but without the runtime for a DSL and all of that, just pure simple functions. And this is actually amazing. With functions, you can do something as close as a DSL or looks like a DSL is mind-boggling to me. There's
Yes.
Hi, it's
Hello.
amazing talk.
Thank you.
What I'm going to
Never
say
heard
now
that,
is,
but
no, it's really cool. It's not exactly a question, it's more like an addition to this REST API stuff you showed.
Mhm.
In the iOS community, at least the past few years, we've been always kind of told, start with protocol and all that. And
there's
yeah,
a
I
famous
was-
talk about that.
Yeah. What I'm saying now is that I think you could add that it's really interesting to compare what you show now to, the protocol-oriented
Mhm.
approach and see the plus and cons.
I could have, yeah.
Because doing the stuff you've been doing, well, as you said, mocks are very much simplified. You don't have to, when you create that stuff, you don't have to add everything, and it's easy to just slap a part you want and stuff like that. So that's really important. Like, just saying for people who liked what they saw here, they should try looking more into how they, where this applies and how they can simplify their own code. Because just looking at, okay, you put functions around, you swap them around, it's kind of fun, but what does it give it to actually?
Exactly.
But if you look deep enough, it waits for you there. It's really fun.
It does. That's a really good point. Thank you for bringing it up. This is kind of, and you seem to be an insider, so you know what's going on. But we have this kind of feud between people who really think protocols should be everywhere in Swift. I mean, not really a feud, but more like a thing. And I think protocols, and I have here in the audience an ex-colleague where we used in some projects a lot of protocols, and the situations, they were a bit hard to work with because you end up with a lot of protocols everywhere. The reason I didn't mention them too much is I wasn't aware how much of the audience is familiar with the protocols in Swift. Also, I feel like bashing on protocols become a bit too sort of cliche at this point too, just like bashing on OOP. So, yeah, I left that out.
Yeah. Any more questions?
What?
Yeah.
Yeah, thanks. So the question is about just developer experience. So you need to write kind of a lot of plumbing code and maybe code that's project or company specific.
Mm-hmm.
How do you introduce that to new developers? Because obviously Googling how do you get a token with Swift will not give you
No.
code you wrote. So do you have any opinions on that?
This is an excellent question because I think the biggest thing, if I had to put a slide here with drawbacks of this approach, would be people's familiarity. So a lot of people not familiar with the functional way of doing things, just look at things and okay, I don't understand what I need to do. My short answer to that is nothing can beat really good documentation. So if you're the author of this and you have a team of people, you have to sit down, write put a markdown file and write how this thing works, give examples. For instance, list some of these requests. If you don't have that, of course, you're letting the people basically drown, because they will like, okay, what am I looking at here? What's possible to do? They won't see that from the get-go. I think it's definitely a struggle. I had situations where people just didn't really subscribe to any of this. It's like, oh, I'm not sure I need this. I can just create the request myself and pass it around. And that's actually valid. You can do that. But on a scale, it won't work. Like, you can do that solo, but then 2 others will do it slightly differently. They will tweak the request in a different way. And then when you have 30 people in the team, each one doing their small little thing, it's not going to scale. And for some areas like networking, I prefer to have a very, let's say, I don't want to use the word strict, because this is not strict. You can still do whatever you want, but at least opinionated API so that people can follow. Things like security, networking, I usually don't value a lot how easy is it to modify things more than how easy to build correct code and that's tested and all of it. To me, this always kind of tips the balance a bit. But to your point, it's definitely a problem. And it's something that always keeping me sort of thinking, how can we improve it? Education is one other thing as well. So other than documentation, like education and talking, but having this talk here is part of that, actually. I feel like more people need to know about this stuff, because then when you see it, they get scared. Just click around. It just functions. Like, nothing really scary here. So yeah, thanks for the question, though.
Do we have any more questions? No.
All right.
Thank you. Great presentation.
Thank you.
Yes. With that, thank you everyone for visiting tonight. And thanks to the presenters. And I also shout out to Alex and the team at Volvo. Thank you very much for helping out arranging and fixing and putting up chairs and everything. Yeah, thank you very much. With that, tonight. Yeah.